Hello dear students, welcome back to NEET World, and we are very happy to launch our IPE course for our upcoming AP and TS IPE examination for both 11th and 12th. Okay, so now these sessions are conducted everyday live sessions for both physics, chemistry, mathematics as well as bio subjects. Okay, so for all these MPC students and BPC students, these sessions are highly helpful for your preparation. Okay, so now this is our first session for chemistry, so this will be useful for all the first year students here. So just look at here. So in this particular session I will be covering the best strategy for your IPE first year exam, as well as the important questions, like all the important questions that must be studied to get 60 out of 60 in your IPE exam. Okay, so just watch this session completely till the end. Definitely you are going to get complete clarity on your preparation for your IPE exam. Okay, and this session will be in both Telugu and English communication, so you can just follow this session till the end. You will definitely get some clarity on your preparation, how to make your preparation more effective. Okay, right. See, ఇది అందరికి IPE ఎగ్జామ్ ఫస్ట్ ఇయర్ IPE ఎగ్జామ్ ఎవరైతే ప్రిపేర్ అవుతున్నారో అందరికి కూడా చాలా యూజ్ అవుతుంది. సో జస్ట్ మీరు వాచ్ చేయండి till the end. See, I am going to share you the perfect strategy, as well as like what are the chapter to be focused for long answers and short answers. Everything is discussed. And next thing is, what are the important questions from each chapter, what are the top LAQ questions we need to choose. All these things will be going to be discussed here. Just focus till the end. Definitely you are going to get complete clarity on your IPE preparation. Okay, right. So look at this. First of all, let us understand the blueprint of our exam paper first. Okay, so now look at this. First of all, see, chapter wise blueprint here will be giving first. See, let's understand the question paper pattern first. See, the question paper contains 3 sections right now. So section A and section B and section C. We have 3 sections, right? So in first section we have 10 questions. How many questions? 10 questions. I hope you know this, but there are some students might not be having complete clarity because they are just 11 students only right now. So for them might not be having complete idea on their exam. That's why I'm just giving you the exam pattern also. See, there are 10 questions. These 10 questions compulsory ga attempt cheyali. All the 10 questions must be attempt. Okay, each question carries 2 marks. Therefore, all total marks are 20 marks in section 1. Okay, so VSAQ, very short answer type questions are 10 questions are there and 2 marks each. Total marks are 20. I hope section 1 is clear. And when it comes to section 2, or that is what section B, see, there are total 8 questions. How many questions? 8 questions each, and out of these 8 questions we have we have some comfort of taking only 6 questions out of this 8. See, so you can choose any 6 out of this 8. So choose any 6 and each question carries 4 marks. Therefore total 24 marks in your section B. And what about section C? So section C contains 3 questions. How many questions? 3 questions, and you can choose any 2 questions out of these 3. So 2 questions and each question carries 8 marks. So total 16 marks are there. Okay, so now what is the total number of marks in this question paper? So just add all these things, you will get total 60 marks. Okay, so this paper is of 60 marks paper, having section A 20, section B 24, section C 16 marks. That's it. This is the best simplest way to understand your question paper pattern. Okay, hope this is clear. Okay, hope this is clear. Right. And the next thing is, I will be now giving you what are the important questions that must be focused for section C first, because there are 2 questions that must be attempted. Each question carries 8 marks. Right now, out of these 3, you need to attempt 2. Each question carries 8 marks. And how important it is, like you are going to get 8 marks with the help of 1 question. And those questions are very easy, and there are very few chapters to be focused. I am going to give you just 12 questions maximum of 12 questions I am going to share you for this LAQs. How many questions I am going to give you now? Only 12 questions I am going to share you. Out of these 12 questions, definitely you will get the 2 questions. Whatever these 3 questions are there, so that 3 questions definitely from this, or at least 2 questions from these 12 LAQs you are going to write in your exam. Okay, mostly this will be the scenario. Out of these 12 only there will be the questions, because I have collected these questions by looking at the previous year papers, like what are the scenarios, what are the way they are following, like what is the, I can say, the tradition that they are following from last years, like past years, like past 4-5 years, they are giving the questions only from these 12 questions. See, these 12 questions is more than enough, I felt. Okay, now let me give you that first, and after that for section B also I'm going to share you the questions from each chapter as well as section A also. Okay, just look at these. Look at this. What are the chapters to be focused for this LAQ type of questions? See, these are the 4 chapters to be focused to answer this LAQ. Okay, so LAQ contains 8 marks each. Okay, and what are the chapters you need to focus? One is structure of atom or atomic structure and classification of elements and organic chemistry. Okay, mostly it will be fixed. One question from structure of atom, okay, and one question from classification of elements. And the third question is there now. It is mostly from any of these 2 chapters, and here also almost 70% chance from this organic chemistry only. Very rare case they may ask from this chemical bonding. I hope you got the clarity that what to cover here. Now you need to cover first structure of atom. So out of this chapter you just need to cover only 2 questions. Out of these 2 questions you are going to get 1 question. Okay, I am going to share you that, no worries, just hold on. And from classification of elements also there are 2 questions from which you can expect 1 question. Okay, that very important questions, again I am saying. Okay, then next, out of these 2 definitely there will be a question from organic chemistry only, most probably. Okay, if it is missing, then we are going to get a question from this chemical bonding, no worries. See, if the question 8 mark question is from organic chemistry, then your 4 mark questions are from chemical bonding, or in the reverse manner. So whatever you are studying, that will not be wasted. Okay, if that 8 mark question from chemical bonding is not asked here, that will be asked in the 4 mark session. That's it. Okay, so just look at this list of questions from each chapter to get complete clarity. See, the 4 marks questions from 8 marks questions from structure of atom to be focused from this chapter, like structure of atom. Out of these 3 questions you can expect 1 question. ఈ 3 క్వశ్చన్స్ లో నుంచి ఒక క్వశ్చన్ కంపల్సరీగా ఫైనల్ ఎగ్జామ్ లో ఉంటుంది. సో మోస్ట్ ప్రాబబ్లీ దట్ ఈస్ Bohr's atomic model. What is that? Bohr's atomic model, like what are the Bohr's postulates, okay, and its limitation, and also like hydrogen spectra in hydrogen atom. So just read this question. What are the postulates of Bohr's model of hydrogen atom, and discuss the importance of this model to explain various line spectra in hydrogen atom. See guys, and one more thing I just wanted to give a clarity on this. See, in this today's session I will be giving you the list of important questions first. So what I am going to share, first of all I am going to share you the list of important questions, and from next session onwards we are going to cover all the important questions, I mean with the explanation, with the clear explanation of this important question, with the clear explanation of its answer. See, these are the questions. You just make a note of all these questions. In the next session, that is on Monday session, okay, we are going to get a pure complete discussion of how you need to attempt your exam, and what is the best way to attempt this answer in your final exam. All the things will be clear, I mean explained in the upcoming sessions. Just as of now we'll make list of all the important questions first. Take a screenshot or you can make a note of these questions first. Okay, and then next, quantum numbers, any of the question from these 2 will be definitely there in the final exam. Okay, that is for sure. Okay, and the same first question can be asked in this way. Write the postulates of Bohr's atomic theory. Yes, out of up to here it is same. Okay, mention the limitations of the model. Okay, what are the limitations, and along with that extra part will be differentiate between emission spectra and absorption spectra. That's it. So Bohr's model, one question, and next quantum numbers. These are the two questions to be focused from structure of atom for sure. Okay, and then next here classification of elements. So each chapter lo nundi definitely a question asking about periodic properties. ఈ periodic properties అంటే ఏంటి, atomic radius అంటే ఏంటి, ionization energy, ionization enthalpy అంటే ఏంటి, and the next electron negativity అంటే ఏంటి, electron gain enthalpy and ionization energy. These are the periodic properties that we must focus from the classification of elements. Okay, right, and a clear discussion of this question will also be going to be done in the upcoming sessions. Okay, we are going to do all the discussions like each and every question with a clear cut explanation, and you know you are no need of worrying about your test materials, like how can you get the answers, where even if you are not having your materials, no worries, we are coming up with very good surprises in upcoming sessions. Okay, we are going to provide all the answers for these questions along with their clear cut discussion. Okay, no worries, just click on the subscribe button, and just stay connected with us. That's it. This is then everything will be done in the upcoming sessions. Okay, right, look at this, either periodic properties they may ask, or they will ask what exactly ionization energy. This is also periodic property only. What exactly ionization energy, that is first ionization energy and second ionization energy, and why second ionization energy is greater than first ionization energy. Okay, so this kind of questions they may ask, and what are the factors that are influencing on this ionization energy. Okay, that's it. This is one more question. Okay, and then next look at this is one more expected question. See, write a brief note on general characteristics of DSPDF block elements. Like just they are asking about periodic table. What are S block elements, P block, D block and F block, that's it. This is one more question. These are the three questions from classification of elements. Okay, and then next when it comes to organic chemistry, and guys, most of these students will skip this organic chemistry without having any reason. They just feel that this chapter might be difficult. No, I will make it very simple and very easy. Just follow our sessions, that's it. Okay, see, if you cover this chapter, I mean these many questions, definitely you are going to answer this LAQ question, 8 marks question, or in case along with this 8 marks question, there is a high chances of getting your VSAQ question from this list of reactions only. Okay, so everything LAQs and VSAQs, everything is going to be discussed, both organic, inorganic as well as physical chemistry. No need to worry. Okay, just look at the list of questions, describe the methods for preparation of ethane. So how do we prepare ethane? Ethane ni ela prepare cheyali ante simple. I will explain that. Okay, next write the chemical properties of ethane with suitable examples. So chemical properties enti, ethane yokka chemical properties, like how it will be reacting, all these things will be given. Just stay connected. Next, explain two methods of preparation of ethylene, that is nothing but ethene. Ethene ni ela prepare chestaro ani adugutunna. Okay, so write the reactions of ethene, like this ethene with hypochlorous acid like HOCl, how this HOCl will react with this ethene, and how this cold dilute KMnO4 react with this ethene. They are very simple. I am going to explain everything, just stay connected. Okay, so mention two methods of preparation of acetylene. So ethane ni ela prepare chestam, C2H2. How do you prepare this C2H2? This is a question asking. Okay, so how is benzene obtained from acetylene? See, polymerization of acetylene gives benzene. Okay, this kind of reactions, everything is mentioned, I mean will be given from my side. Just stay connected. I am going to cover all of them in very easiest way possible. Okay, so next, explain halogenation, alkylation, acylation, nitration, sulfonation of benzene. That's it. Okay, these are the list of questions from organic chemistry. And finally we have chemical bonding. This is an extra chapter to be covered here. See, I am saying extra chapter for LAQs. If these questions are not in the LAQs, 8 marks question, definitely out of these questions only we can expect SAQ question. Okay, from these 4 questions only, from these 3 questions only we can expect one as SAQ question also. So no need to worry, like you are not going to waste your time by preparing these questions, because same question will be repeated in SAQs if not in LAQ. Okay, so now what I mentioned here, what is a hybridization? Explain the different types of hybridizations involving sp orbitals. Okay, then next, like sp orbital means we know now, like sp hybridization is there, sp2 and sp3 hybridization, like this. They are going to ask about this thing. Okay, remember this. Okay, then next, give an account of valence shell electron pair repulsion theory and its application. Okay, so what is this valence shell electron pair repulsion theory and its application they are asking. Okay, this is also important. And then next, molecular orbital theory and its energy diagram for N2O2. Okay, so this is also important questions. Okay, remember, and do not by heart the question any time in any exam. Okay, even if you are preparing for boards IPE exam also, do not by heart the question, because these things are very helpful if you are going to prepare for JEE, NEET or your EAP set exam. Definitely these sessions are even useful, or you can make it useful for your EAP set preparation also along with your IPE exam. So what is the only thing, you should not by heart the thing, you should learn the concept. Okay, try to learn the concept, understand the concept instead of remembering it randomly. Okay, right. Next, so this is about what? 8 marks question list is over. The next 4 marks questions are asked from these chapters. Short answer SAQs are from this many chapters. Okay, so it is from chemical bonding, states of matter, stoichiometry, thermodynamics, hydrogen and its compounds, p block elements like 13th and 14th group. The next, organic chemistry. So these are the chapters to be focused for 4 marks questions. Okay, so we have 8 questions. Out of this 8 we need to write 6 4 marks question. Each question carries 4, so 24 marks from this section B right now. So now what are the exact questions that can comes from this chapter? So let me show you that list here. ఈ క్వశ్చన్స్ మీరు కంపల్సరీగా కవర్ చేయాలమ్మా. ఓకే, సో in order to get maximum marks in your IPE 60 out of 60, if you are aiming for 60 out of 60. And guys, you know, if you are fearing for your IPE preparation, no worries, so you can easily score even if you are preparing, if you haven't started your preparation. So now if you start the preparation, definitely you can have maximum probability to score 60 out of 60 without having any worries. Okay, so we'll help you in all your preparation for maths, physics, chemistry and bio subjects also. So just you need to stay connected with us and take the list of all the questions that we are sharing here. Okay, these are definitely helpful. See, all these questions are asked like multiple times, like 5 times, 10 times, like that. Some questions are there even 10 times asked. Okay, see, what is the first question here? Explain the structure of PCl5 molecule in terms of sp3d hybridization. States Poisson's rules with suitable examples. Okay, this is one question. Okay, see, if you learn this Poisson's rules here, definitely it will helpful in your EAP set exam also. Next, explain the structure of SF6 molecule on the basis of sp3d2 hybridization. So how we are getting this sp3d hybridization, how we are getting here sp3d hybridization in case of PCl5. This is what we need to explain them. Okay, and after this, see, Poisson's rule, again Poisson's rules they are asking. Next, what is hydrogen bonding? Explain different types of hydrogen bonding, like we are saying now intramolecular hydrogen bonding and intermolecular hydrogen bonding. Yes, we need to give a detailed answer on this, that's it. Okay, next, explain the formation of coordinate covalent bond with one example. Okay, how this coordinate covalent bond is formed. For example, we have BF3 here, so it has a vacant orbital. To that NH3, if I take one example, so now NH3 molecule only donating pair of electrons to this BF3. Yes, so if a species is donating pair of electrons to make a bond, okay, so both electrons are coming from one particular species for making a bond, then we can call it as a day2 bond or coordinate covalent bond right now. So this is a coordinate covalent bond. Okay, that's it. I'm going to give complete explanation for that in detail, no worries. Next, write the general properties of ionic compounds. So what are the general properties of these ionic compounds to be mentioned? That's it. Okay, this is from chemical bonding, and these are the questions from states of matter like ideal gas equation, and important postulates of this KTG or kinetic molecular theory. Okay, kinetic molecular theory. Next, derive the like we need to derive Boyle's law and Charles' law from this ideal gas equation, kinetics gas equation. Next, deduce Graham's law of diffusion, like Graham's law from kinetic gas equation. Next, Graham's law of diffusion, we need to state and explain this Graham's law of diffusion. Okay, these are the questions to be focused from the states of matter. Okay, right. Next, look at this from thermodynamics, very easy. Hess law, very easy, this one is. And the next, Hess law we need to study. And the next, what do we mean by heat capacity? What is the relation between Cp and Cv? Cp minus Cv equals to Nr we are saying now, or Cp minus Cv equals to R we are saying now for 1 mole. So we need to show that how this equation is obtained, that's it. And third question is, and one more question is, state third law of thermodynamics and define entropy. Okay, so these are the 4 marks question from thermodynamics. Next, these are KP-Kc relation, and the next Le-Chatelier principle. Okay, and discuss the applications of Le-Chatelier principle in the manufacturing of sulfur trioxide by contact process. So what is the use of contact process? These things are we need to focus. Okay, these things we need to focus. Okay, then next, explain Bronsted-Lowry's acid-base theory with one example. So what do we mean by Bronsted acid-base theory? Okay, so species which donates a proton can be called as acid. Species which accept a proton is called a base as per this Bronsted-Lowry acid-base theory. Right now, I am going to discuss them very clearly, no worries. Explain Lewis acid-base theory with example. So these are the questions from chemical equilibrium. And the next, hydrogen and its compounds. Again, take a screenshot of all these questions we are going to discuss in the upcoming sessions for this hydrogen and its compounds also. Okay. Guys, just tell me, did you started your preparation for IPE or not? So if you are in the live session, just mention if you are started your preparation or not. If started, just mention yes in the chat box. If not, just start your preparation for your IPE. Do not wait for the last minute. Okay, because this is your first time that you are going to attempt your intermediate exams right now. So you haven't got, you are not aware of this, how this intermediate board exams will be. Okay, so now what is your main duty here? Since you are a first year student, start it little early, start your preparation little early, then you will get more confidence. Okay, and you can make your preparation more effective with the confidence right now. So at least start it right now, from at least today or tomorrow you just start your preparation, and you have 1 month of time, like complete preparation can be done in the next month also along with this month. Okay, right. So look at this, like we need to say what are the uses of hydrogen, okay, as a fuel. Okay, how can you explain terms hard water and soft water, and what are the methods to remove that hardness of a water. Okay, these are the questions to be focused here. Then next, from P block elements, these are the questions like what do we mean by borax bead test, with explain with a suitable example. Next, structure of diboron, very important mark. Even IPE they will ask this diboron question, or they will same concept can be used for your EAP set also, because for EAP set this is a favorite question, favorite topic of like diboron from this 13th group elements. Okay, and the next, what are electron deficient compounds? Like BCl3 is an example for electron deficient compound. So just we need to explain how it is. Okay, so difference difference in the properties of diamond and graphite based on their structure we need to write. And the next, what do you understand by allotrophy and catenation? These are the questions from P block. Okay, right. And these are the questions from organic chemistry. Okay, hope all your 4 marks questions are taken. Okay, so these are the all 4 marks question you must focus in order to get your 24 marks from your section B. From section B, if you want to write 6 out of 6 questions, you need to focus these questions for sure, definitely. Whatever the questions till now I have projected here, you must cover all those questions. Okay, so if you have extra time, yes, then after you can do those questions also, but first of all you need to cover these questions. Okay, right. Hope you have taken the list of all these questions. Yes, someone in the chat box, yes, you can feel free to express your concerns. Alpha in the chat box. Right. So next I am going to share you some list of very short answer type questions, VSAQs. These are just 2 marks questions, but these 2 marks questions will decide your 60 out of 60. Your 60 out of 60 is decided by these VSAQ questions only. Okay, because there is no option, like there is no choice of choice from the questions, like you need to attempt all 10 questions here. It means you should get complete clarity on each and every important term. First of all, important terms that are used from each chapter to be covered first of all. Okay, so if you are opening like for example, if I consider any chapter, like here I have given states of matter. So what are the important laws we have, like ideal gas equations we have now, Boyle's law, Charles law, Avogadro's law, Gay-Lussac's law, all this should be covered in order to get maximum marks. But from that also I have simplified this many questions. See, Graham's law of diffusion, that is covered either in 4 marks or here. The next states Dalton's law of partial pressure. Okay, and then next, so why pressure cooker is used for cooking food on heels. Okay, how it will be used. Next, among N2O2 and methane, which gas diffuses faster, give reasons. How it will be related to the Graham's law of diffusion. That is very easy now. You can easily answer by linking it to the Graham's law of diffusion. I am going to share you, no worries. Next, give like we need to find how many times methane diffuses faster than sulfur dioxide. See, these questions are like, you know, now like we can answer it with respect to this Graham's law of diffusion based on their molar masses. Okay, and there are some questions which are asked as a numerical type based also. See, I am not skipping this numerical based questions also. You can easily solve if you watch our sessions here. Okay, so we will be covering theoretical questions as well as numerical answer type questions also. No worries, just stay connected with us. See, calculate kinetic energy for 5 moles of an ideal gas. So what is the kinetic energy formula to be used here to calculate this? Okay, we are going to share. Then next, you know that RMS velocities we are calculating now, you are using the same formula in your physics also. RMS, next most probable velocity, average velocity. So same things will be comes here when it comes to numericals. Use those formulas to calculate here, like in KTG you might be studying that. Okay, if you are a like EAPC student or NEET or JEE student, you might cover those topics by this time. If not, no worries, I am going to explain them here with a clear cut explanation. Okay, so again, okay, up to here it is clear now. See, now I have just provided only one chapter MCQs like this one, very short answers from only one chapter I have provided here. Okay, because there are like many questions from this very short answers, like very important questions are, there are many questions. I have a big list of those questions. Those I am not going to share here right now. I will be giving you definitely, but as of now you just get some clarity on whatever the questions I have shared. Okay, again I will give separately this VSAQ questions for each chapter when we are discussing this VSAQ questions. Okay, and if you want this list of questions as a PDF from our side, so just join our Telegram group. So where to join this? Join our Telegram Telegram group. So how do you get this link or the mobile number of this Telegram group? Everything will be provided in the description. You can join through that. Okay. Or if you want to download this PDF, just go through MedWorld app. What is this MedWorld app? This is our NEET World's official app where we will be providing this free content in the app itself. Okay. So you can download this app and you can access complete list of important questions in that MedWorld app. Okay. So you are going to get this in that MedWorld app. Just go to Play Store, search for MedWorld app and download it, and you can access this PDF list of important questions. Not only this, you are going to get lot of surprises in this MedWorld app for free of cost. Your complete IPE preparation can be done from your MedWorld app with free of cost. So just go download it and stay connected. That's it. Okay. If you want any PDF material, just go there, just message there in the chat box of this MedWorld app. Definitely our team will respond on it and they will share you the list of the important things that you are looking for. Okay. Right. And then next, see, I am going to show you one sample question that I am going to discuss in the upcoming session. So sample question means, look at this. First question here I have brought. What is the first chapter we know? So that is atomic structure now. So from atomic structure, what are the questions I told you? LAQ questions are there now. So what are the questions? Only two important questions are there. That questions are what? Like Bohr's atomic model, and the next question is, quantum numbers. Only these two questions to be focused from that chapter. Okay. So now let us take first question and let us discuss this question. Let me explain this. See here, what are the postulates of Bohr's model of hydrogen atom? Discuss the importance of this model in explaining the line spectra of hydrogen atom. Okay. So what is a Bohr's model's postulate? See, it is very easy. Okay. Just look at here. So what Bohr's atomic model consider here is, see, atom contains a nucleus at the center around which electrons revolve in a circular path. What happens? Atom contains a nucleus at the center around which electrons are revolving. See, what is the postulates? Electrons revolve around the nucleus in the fixed circular paths called orbits. What they are saying? Electrons revolve around this nucleus in fixed circular paths. So these circular paths are called orbits. What they call? Orbits. Okay, these circular paths are called orbits. Okay, so these circular paths, I mean these orbits are certain definite paths, like they have certain definite paths in which electrons move without radiating energy. So when these electrons are revolving in these circular paths, they do not radiate energy. First of all, you need to understand this concept very clearly. See, there is a nucleus at the center of an atom around which electrons are revolving. So here electrons are there, these are revolving around this nucleus in these circular paths. Okay, so these circular paths are having fixed radius from the nucleus. See, this is the center point of the atom, that is what we are saying, nucleus. Okay, this is circular paths in which electrons are revolving. So these circular paths will have a fixed radius. What they are saying? They have a fixed radius from here to here. Radius is fixed now? Yes, radius is fixed. Okay, and from here to here again one more, like this is R1, this is R2 radius. Okay, there is a fixed radius. Okay, now when an electron is revolving in this fixed radius, we can say them this radius, these electrons are having fixed energies here. So electron revolving in this orbit, this shell, this level orbit will be having some fixed energy. Okay, and if it is revolving in this, that will be having some fixed energy. Okay, these are not equal, but it is having some individual energy, and this is also having some its individual energy now. So those energies are fixed. So what we can say them? So these energy states like 1, 2 we are writing now. So these are called stationary states or stationary orbits and having energy fixed now, so fixed energy levels also we can say. Okay, what I am saying, fixed energy levels indicated with symbol n equals to 1, 2, or it can also be indicated with K, L, M, N, like that we can indicate. Okay, so as the shells increases we can indicate it as 1, 2, 3, 4, so on like that, or K, L, M, N, like that we can indicate. Okay, right. Hope this is clear. Up to here the discussion is clear, right guys? So if you are new to this channel, just click on the like button, and also do not forget to subscribe the channel first. Okay, so if you do not want to miss the updates from our side, just click on the follow button first of all, I mean subscribe button. Okay, right. Up to here discussion is clear now. So now what they are saying, these orbits are having defined paths right now in which electrons are revolving. So now whenever electron is revolving in this, that electron will not radiate energy or will not absorb energy. What they are saying, if electron is present in this level, for example I am saying electron is present in this second orbit. So what they are saying, this electron will not emit energy or will not absorb energy. But if in case, what they are saying, but if in case it emits any energy, if this electron emits any energy outside, therefore energy of electron losing now, so then that electron falls into lower energy state. If in case electron emits energy, electron falls into lower energy state. So from here to here it is falling now. So from here it will comes into lower energies. So it will comes from here to here it will be now. Okay, so now why it is falling down, because it is losing energy now when it is emitting, that's it. If an electron emits energy, falls to lower energy state. Okay, now it is emitting energy now, so what it is doing, it is giving some energy outside, that is indicated like this. Okay, then it falls to lower energy state. And one more factor he told, that one more point he told, and if it is absorbing energy, if electron is at here, if that electron is absorbing some energy, okay, if that energy is suitable from moving from here to here, then electron jumps from lower energy state to higher energy state. So if a suitable amount of energy is supplied to this electron, it jumps from this lower energies to higher energy. Then we will get some energy difference. From here to here we have some energy difference, from here to here we have some energy difference, like that we are going to get. See, when an electron is falling into lower states, it is emitting energy. If we absorb that emitted energy, we will get emission spectra. What we are going to get? Emission spectra. We are going to get an emission spectra. If an electron absorbing energy and that electron is exciting to next level, you can say that as absorption spectra. Absorption spectra. Now he is clearly explained that there is two types of spectra. One is emission spectra and absorption spectra. So how this spectra comes? When electron emits energy, that falls into lower energy state, and whatever the emitted energy is there now, that will be reason for this emission spectra. Okay, and one more point what he told, if an electron absorbs energy, jumps to higher energy state, that whatever the absorbed energy is there now, so that will be the responsible for this absorption spectra. That's it. These are the points to be remembered here. Okay, right. The next thing is here, you got clarity that every orbit is associated with some particular energy. So these orbits are known as energy shells or stationary shells. So these orbits are known as what? Energy. See, whatever the theoretical information I am providing here, just for your reference, I will be giving you complete explanation like this, and you can use these points, and whatever points coming out of my mouth, just make a list of those and you make your best answer in your own words. That's it. See, examiner will see in what way, what is the best, simplest or best way that you are going to present in the exam. They won't look for the direct bookish answer there. Okay, you need to present the answer in the best possible way. That's it. Okay, so they won't expect that answer should be same as in your book. Okay, so different material, different answers will be there. No worries about those kind of things. Do not by heart, try to understand the concept. Okay, so what is the first point? electrons revolve around the nucleus in the circular orbits. Okay, so those circular orbits have fixed radius and fixed energies, therefore they are called as stationary states or stationary orbits. Okay, and now electron will not radiate energy when it is revolving in those circular paths, in that stationary paths. Okay, and if in case if electron is absorbing some energy, then electron jumps from that lower energy state to the next higher energy state depending upon the absorption of energy. Okay, and if in case energy is released by the electron, then the energy of electron is losing now, then that electron goes to the lower energy state. So these are the 2 points reason for their spectra, either emission spectra or absorption spectra. That's it. Okay, hope the discussion is clear up to here. Then next, now what I told you, they are indicated with KL, MN, or 1, 2, 3, 4 we discussed already. Okay, so now see, as long as electron is moving in the permitted paths, it will not emit energy or absorb energy. Okay, this everything is clear. Then next, one more point here, what I told you, this is a nucleus around which electrons are revolving, we discussed right now, around which electrons are revolving, we discussed. Okay, now only see, there are many circular paths available here. Like see, if this is a nucleus, we can make a circular path here or here or here, some random circular paths we can make, but all circular paths will not be allowed. Okay, all paths, what I am saying, all paths are not allowed, only those circular paths are allowed. Electron will revolve only in those paths, in those circular paths whose angular momentum is equals to integral multiple of h by 2 pi. What I am saying, all paths are not allowed, only those circular paths are allowed whose angular momentum is equals to h by 2 pi. It means nothing, just look at here, see, this is a nucleus, okay, and this is a circular path in which electron is moving. Okay, so now the angular momentum of this circular path must be, angular momentum I am indicating with a symbol L, this must be equals to nh by 2 pi. What I am saying, this must be equals to nh by 2 pi. See, angular momentum for this circular path is given with this manner. See, it is moving with at a distance r now, with some theta here I mentioned with an angle theta. Okay, so this electron is having some mass m now, so having mass m and moving with velocity v, mv, and at a distance r, that is radius r. Okay, mvr sine and with a theta sine theta, that's it. So mvr sine theta is equals to nh by 2 pi. Okay, so angular momentum, this is mvr sine theta equals to nh by 2 pi. See, now what is the angle here, we have 90 now, so sine 90 is how much? I hope you know that sine 90 is 1 right now. So this will becomes now mvr is equals to nh by 2 pi, that's it. This is what you need to remember here. Okay, so only those circular paths are allowed whose angular momentum is equals to integral multiple of h by 2 pi, that is mvr is equals to nh by 2 pi, that's it. You need to write this 1 point to get 1 mark out of that 8 marks. It means this must be present in the paper, then only you will get your marks. Okay, so these are important points, this is very important point. So what is the name of this point? Quantization of angular momentum. What is that? Quantization of angular momentum. Okay, right. The next, along with this, up to here everything is clear now. Yes, if this discussion is clear, just mention clear in the chat box. ఇక్కడ దాకా అర్థమవుతే జస్ట్ కామెంట్ బాక్స్లో క్లియర్ సార్ అని మెన్షన్ చేయండి. ఇంకా మీకు ఏదైనా డౌట్ ఉంటే కామెంట్లో అడగండి, ఐఎమ్ గోయింగ్ టు క్లియర్ ఇట్ అవుట్. ఓకే, ఐ హోప్ మై డిస్కషన్ వాట్ ఎవర్ ఐఎమ్ ఎక్స్ప్లెయినింగ్ ఇట్ ఈస్ క్లియర్. Yeah, next thing, let me take some water. Yes, alpha, clear, right. Yeah, the next discussion, So what I told you, if an electron jumps from lower orbit to higher orbit, it absorbs energy, or if electron falls from higher orbit to lower orbit, it emits energy. Okay, so how much emission, like how much amount of energy is emitted or absorbed, that will be given like this. Delta E is equals to E2 minus E1, E2 minus E1. E2 minus E1 means what? See, E2 minus E1 is nothing but, just look at here, see, if this is the nucleus around which we have orbits right now. So if electron is going from this first orbit, first level to second level, jumping from here to here, so now this is having some fixed energy, this is having some fixed energy, therefore I am saying this is E1, this is E2, therefore delta E, energy difference is how much? Final minus initial, E2 minus E1. Okay, this will be giving us delta E is equals to E2 minus E1, that is H nu. Whatever the postulates we have discussed till now, everything must be mentioned. Okay, then only you will get good marks in the exam. Okay, that's it. This is for higher energy, this is for lower energy. Okay, now I hope you know that energy will be associated with some frequency. Now energy will be associated with some frequency. We are writing E is equals to H nu, right? So nu means what here? Frequency. Okay, so more is the frequency, more will be the energy. Okay, so every energy will associated with some frequency, that's it. Nu represents here frequency, and where H represents Planck's constant. What is the value? 6.6 into 10 power minus 31 joule, 34 joule second. This is the value of H. Okay, you can take these values. Okay, right. Everything is clear, I hope, up to here. Next, so now up to here we studied now. So now I have given one angular momentum quantization formula. What is that? MVR equals to, what I have given? MVR is equals to NH by 2 pi I have mentioned. Okay, so from this you can get a relation. See, dependency of orbit size on quantum number. See, what is this quantum number? See, I have introduced a number n here right now, so that n is nothing but principal quantum number, that is nothing but shell number. How many, like, see, if this is nucleus, around we are writing the circular paths now. This is n equals to 1 we are saying, n equals to 2 we are saying, like this now. So these are n 1, 2, 3, 4, these are nothing but, what is that? Quantum numbers. Which quantum number? Principal quantum number. So now we are going to get a relation between its size and quantum number. See, radius is nothing but size only now. See, more is the radius, more will be the size now. So now radius is directly proportional to quantum number. Radius is directly proportional to quantum number from that. Okay, so more is the increment in this quantum, principal quantum number, more will be the size. So now what I am saying, as value of n increases, see, as value of n increases, see, distance is increasing or not? Yes, increasing. So if distance is increasing from the center point, we can say radius also increasing. So as value of n increases, the radius and energy of orbit also increases. That's it. Thus outer orbits are larger and have higher energy. So as we move from center, I mean from this close to the outer part of this atom, what happens? The electron which is present in the outer part, like valence shell, the last shell, will be having greater energy. You can say greater energy. The outer orbit will be having greater radius and higher energies. Remember this point. Okay, this is just for your understanding on based on this particular relation. That's it. Okay, next, one more thing here is, look at this, second point, explanation of hydrogen line, hydrogen spectrum, hydrogen line spectrum. Okay, so what exactly here? See, just now we discussed, if an electron jumps from higher energy state to lower energy state, it will emit some energy now. Okay, so that energy will be what? Energy will be responsible for emission spectra. Now see, when an electron in a hydrogen atom jumps from one energy level to another energy level, radiation of definite frequency or radiation of some energy is seen. Okay, that is called as emitted energy, and if it is absorbing the energy, then it will be absorbed energy. Okay, so this gives rise to line spectrum. That is what spectrum got from this only. Okay, so now in case of hydrogen atom, we can have this particular table, very important, this table, spectrum, hydrogen atomic spectrum we can say. Okay, so what they are saying, explanation for hydrogen line spectrum. Okay, see, when hydrogen atom is observed, okay, when this hydrogen atom is taken, so now in this, when it is, see, just look at this, hydrogen shows discrete lines because electron makes quantized jumps from a higher energy to the lower energy. See, when an electron of this hydrogen atoms falls from higher energy to lower energy state, say n equals to 1, n equals to some bigger number, n2, n3, like that we have. So if an electron is falling from here to here, what happens? Lower energy, see, falling from higher energy state to lower energy. See, electron is falling to lower energy. It means it is emitting some energy now outside, having more energy, falling to down energy, lower energy. It means some energy is lost from that electron. So that is responsible for spectra. Now this whatever the energy emitted will show some lines in the spectrum. Okay, so those lines appears in this manner. Okay, so now see what they are saying. If this line is falling, say electron is falling from there to here, now this line will be having some energy associated with some energy. It will be having some energy, that is what E I mentioned, or it will be having some frequency nu we can say, or it will be having some wavelength lambda. So why I am saying this many numbers, see, E is equals to h nu we can write, or hc by lambda we can write. So every energy associated with some frequency and with some wavelength right now. So how can we relate them? So we can have a relation, that is what Rydberg's formula. What is this Rydberg's formula says? See, 1 by lambda, that is nothing but wave number nu bar, which is equals to RH z square 1 by n1 square minus 1 by n2 square. So n1 will be always lower energy state, or if you want you can write n initial, n1 or ni initial, n2 is nothing but n final, nf you can write. Always remember, ni is initial, I mean lower energy state, this is lower energy. Always remember nf should be greater than ni, that's it. Okay, that's it. This is what you need to remember. Okay, so or simply you can make n1, n2 for understanding. It's your wish, completely your wish. n1 and n2 I am writing here, n1 and n2. Okay, always n2 should be greater than n1, remember this. Okay, so now let us understand this more effectively, like this spectra. See, I am writing some lines here, just see here, n equals to 1 I am saying, here n equals to 2 I am saying, here n equals to 3, n equals to 4, n equals to 5, n equals to 6, like that. If it goes, keep on going upside, n values increases and will reach an n value equals to infinity somewhere else at the top. Right now like this we will be getting. So now what I am saying here is, when an electron is falling from any higher energy state to, this is the first state, ground state, we can say that line appears in Lyman series, where it will be, so from any higher energy state, it is, if it is falling into the ground state, that is n equals to 1 state, that will be comes under Lyman series. You can say region will be ultraviolet region, UV region. Okay, if electron is falling from any higher energy state means like 2, 3, 4, 5 like that, and coming to the 1, we can say that comes in Lyman series. That line will be appears in where? Lyman series, and that line will be observed in UV region. See, we will be having now UV spectroscopy, IR spectroscopy, like this we have. So this Lyman series line will observe in UV light region only. Okay, now for hydrogen atom, if an electron is present at higher level, like it can be considered as N2, can be anywhere higher level from 3, 4, 5 like that, and falling into second energy level, from any higher energy state to second energy level. Second energy, this is first energy level, this is second energy level now. So if any higher energy state to this is second energy level, it is falling, then this line will be observed in This line will be observed in Balmer series, where it will be Balmer series line. We can call that line as Balmer series line, and that will be appears in this visible region, where it will be visible region. That spectroscopy electromagnetic radiations we will be studying now. There will be having IR region, visible region, UV region, all these things are there now. So now this Balmer series, all Balmer series lines will appears in where? Visible region. So Balmer series lines means what? From any state to like third energy state to second energy, or fourth energy to second energy, fifth energy to second energy, sixth to second, seventh to second, eighth to second, like that. For any higher energy state to second energy, if it is falling, that appears or that comes in Balmer series and appears in visible region. Okay, and from any higher energy like 2 to 1, 3 to 1, 4 to 1, if it is happening in this way, that appears in Lyman series and visible in, that will be appears in this ultra UV region, that is ultraviolet region, and the line comes in Lyman series line, that's it. Okay, and from any higher energy state to third energy state, if it is coming like 4 to 3, 5 to 3, 6 to 3, like that, that will be called as Paschen series line and appears in IR region. Okay, just remember there are this many lines. One is Lyman, next Balmer, next Paschen, next bracket, and the next fund, P fund, and next one is Hamfari. Okay, these are the lines. Okay, from any higher energy state to N1 level, N equals to 1 level. Okay, then we can call all those lines are Lyman series. From any higher energy state to N equals to 2, okay, second level, then we can call them as Balmer series. So Lyman series lines appears in UV region, Balmer series lines appears in visible region. Okay, and from any higher energy level to third energy level, this is nothing but UV visible, and this will be in IR, where it will be Paschen series lines appears in IR region, and all other lines also, whatever the bottom lines here we have, everything appears in IR region only. Okay, remember them as IR region, like mid IR, near IR, mid IR, far IR, like that you can remember. Okay, these are the things. From any higher energy state to N equals to 4 comes under bracket. Any higher energy state to fifth energy level, fund series, P fund series. Okay, you can say simply fund series, and any higher energy level to sixth energy state comes under Hamfari series. That's it. Okay, so these are the things to be remembered. See, whatever I am giving the concept over here, that will be useful for your IPE exam, and if you understand this concept, definitely useful for your EAP set also. Okay, yes, next. Okay, so what are the importance of this Bohr's atomic model? Tell me, what are the importance? What are the importance here? You can just see importance of this Bohr's atomic models. Okay, so it explains the stability of atom. So how it will be? See, actually if you know the structure of atom, before studying Bohr's atomic model, we will be seeing Rutherford's atomic model and Thomson's atomic model. These things will be studied. Okay, but these theories, Thomson's atomic model, Thomson's atomic model and Rutherford's atomic model will not able to explain stability of atom. Okay, they were failed to explain the stability of atom, but Bohr's atomic model clearly explain that atom like stability of atom by considering some important postulates right now. So electrons are revolved in a permitted orbital, they do not lose energy normally. Okay, even if they lose energy, that will falls into lower energy state but not into the nucleus. Okay, if electrons going and falling in the nucleus, atom will get destroyed, but he never says that electron will lose energy and falls into nucleus. He never used this word. He just told that electron revolve around the nucleus and it will not radiate energy. If in case it is emitting energy, that goes to the next lower energy state but not directly into the nucleus. This is the thing he clearly explained. So that is nothing but stability of atom is explained. Okay, see here you need to be clear whether in the question they mentioned importance of Bohr model or limitations of Bohr model. See, it is importance of Bohr model because I have given two questions on Bohr's atomic model. In one question they have mentioned it as importance of Bohr model. In another question they mentioned it as limitations of Bohr model. Be clear what they are exactly asking. Okay, be clear what they are exactly asking. Okay, first one, it explain the stability of atom, and next one, successfully explained line spectrum of hydrogen and hydrogen like ions. What is this hydrogen like ions? Hydrogen atom contains only one electron. What it contains? Only one electron. Similar to this, hydrogen like ions, it means any species having only one electron then can be considered as hydrogen like atom. For example, hydrogen like species. For example, helium ion I am writing. Helium atomic number is 2. It means 2 electrons are there in helium atom. But I am writing helium plus now. How many electrons are there now? Only 1 electron. So this is also considered a hydrogen like species. Okay, or lithium plus 2 ion. So this is atomic number is 3, plus 2 means you are removing 2 electrons. So it is also considered like hydrogen like species. Helium ion, lithium 2 ion, and beryllium 3 ion, Be plus 3 ion. These are some examples of hydrogen like species. Okay, remember this term. Okay, so Bohr model is applicable only for single electron like hydrogen like species, like 1 electron containing single electron species only. Sorry. So Bohr model is applicable for hydrogen like species only, like single electron species like hydrogen and hydrogen like species only. Okay, hope the discussion is clear. What it will be explained, successfully explained line spectrum, in line spectrum of this hydrogen like species. Okay, now here he introduced a concept of energy quantization in the atoms. Okay, so quantized orbitals only allowed now. That is what he is saying. Next, the theoretical value obtained from Bohr's equation matched with the experimental result of hydrogen spectra. See, whatever the radius we are going to find using hydrogen atomic. See, if I have hydrogen atom, whatever the practical data we will get, what is the radius, first radius of this hydrogen atom, if we find, we will get one value now. So that value and the radius of first Bohr orbit calculated using this Bohr's model 0.529 n square by z angstroms formula we will be using here from the Bohr's atomic model. See, this answer will be R1 will be 0.529. So this value is this value is nothing but equals to the experimental value of this Bohr's atomic model. Experimental value it is found to be 52.9 angstroms or around 53 angstroms, like in and around these values only. So both experimental value and a theoretical value coming from this Bohr's atomic model were having almost similar values. So that's why the theoretical values obtained from Bohr's equation match with the experimental results of hydrogen spectra. So this is one of the very good sign of successful explanation of its Bohr's atomic model. Okay, right. Now there are some limitations. Okay, so if you understand this limitation, that's enough. Okay, this is the last part of this Bohr's atomic model. In whatever the way they may ask you the question, you just need to explain these points, that's it. Okay, see, explains, so main limitations of Bohr's atomic model is what? It explains only hydrogen like single electron atoms only, not applicable for multi electron systems. See, not applicable for multi electron systems. See, it is applicable for like hydrogen atom. It is applicable for hydrogen atom and helium plus ion. It is applicable for helium plus ion, but not to the helium atom. It is not applicable for helium atom, applicable only for helium ion, because it contains 2 electrons now. If it is containing more than 1 electron, this Bohr's atomic model won't applicable. Applicable only for single electron systems only. See, for multi electron species like lithium, helium, it is failed. Okay, next, it cannot explain like line spectral lines spectra, splitting of line spectra. Okay, like you know, this spectra, whatever the lines we have studied till now, like Lyman series lines, like that we have studied now. So those lines, when we place in electric field and in magnetic field, that lines will further splits. So what he said, the splitting of spectral lines were not explained in presence of magnetic field and also in presence of electric field. See, what I am saying here is, it cannot explain Zeeman effect and Stark effect in full detail. What do we mean by Zeeman effect? Whatever the spectral lines we got, see, we are saying some Lyman series lines, something like Balmer series lines now. So these lines, if you place in Zeeman, if you place in magnetic field, where I am saying, if you place that lines in the magnetic field, the splitting of spectral lines takes place. That is called Zeeman effect. But Zeeman effect was not explained by Bohr model, okay? And in the same way, it was not explained about Stark effect also, like splitting of spectral lines in presence of electric field is called a Stark effect. That is also not explained by Bohr's atomic model. So these two were not explained by Bohr's atomic model. That's why we can say this as a limitation. Now, you know, this whatever the line spectra we are discussing, like Lyman, Balmer, that is applicable only for hydrogen like species, not for multi-electron system. Okay, complete Bohr model applicable only for hydrogen like species only, not for multi-electron system. Single electron system only it will be valid. Okay. Next, this will be Bohr's atomic model will contradicts Heisenberg's uncertainty principle as well as de Broglie's wave equation. Okay. So here it will be contradicts to Heisenberg's uncertainty principle. Remember this. Okay. So Bohr's atomic model contradicts Heisenberg's uncertainty. I mean, these two are contradict to each other. Okay. Remember this point. That's it. These are the points to be mentioned in the exam to score maximum marks for Bohr's atomic model. Okay. So what are the important points needed for Bohr's atomic model? I have clearly discussed. If you have still confusions in understanding Bohr atomic model or any other question, feel free to express in the chat box. Definitely I am going to explain them in the upcoming sessions. Okay. So meeku session nachinataithe just click on the like button and also do not forget to subscribe the channel. Okay. Just stay connected with us and share with your friends who are looking for the explanation of every important IPE questions, especially your first year and second year seniors also. If you have any, like your brothers, you can share with them, because in the upcoming sessions we will be covering for 12th class IPE sessions also. Okay, both for Telangana and AP students. Okay, thank you for watching. Stay connected. Thank you.